Yes, so I am a research software engineer in the advanced modeling program of the Accelerator Technology and Applied Physics division at Berkeley Lab. And I'm speaking on behalf of the WarpX team. What is WarpX? WarpX is an open source high performance particle in cell code for plasma physics simulations and for beam physics in general. So it's modeling and simulating interactions between plasmas, lasers, and particle beams. It is built on AMRX for adaptive mesh refinement, scalability, portability, and a lot of other very useful features, such as dynamic load balancing, the whole parallelization structure, and so on. And thanks to AMRX, it runs efficiently on CPUs and GPUs, from laptops to supercomputers. It's developed by a relatively large community of contributors. We've counted over 100 over the course of the last 8 years. And it's been awarded the Gordon Bell Prize for supercomputing 3 years ago for some mesh refinement simulations of laser-driven electron acceleration on some of the world's fastest supercomputers. So originally, the main focus in terms of physics applications was laser plasma interactions for a particular type of particle accelerator called wake field accelerators. And now, since the end of the exascale computing project, we've been expanding a little bit the range of physics applications that we work on. So, for example, we now work on beam-beam interactions for collider physics, as well as kinetic modeling of plasmas for inertial fusion and some alternative fusion concepts. And it's been also used successfully for astrophysical simulations and microelectronics. So originally it was funded by the Department of Energy's exascale computing project up until the end of 2023. And it's currently primarily funded by the SIDAC projects of DOE, so 2 of them, one for accelerator physics, one for fusion. We have very strong partnerships with national laboratories such as Lawrence Livermore and the Stanford Linear Accelerator Center. We have partnerships with research centers like CA, DESI, the synchrotron in Germany, and CERN, as well as universities and industry. We have been growing our partnerships with some private fusion companies such as TAE Technologies, Helion Energy, Rialta Fusion, and Avalanche. And as far as funding goes, looking ahead, it's fair to say that our ability to continue having sustained funding will be linked to our ability to incorporate and integrate AI/ML workflows into our HPC code base. So it's a flexible, modular, and extensible code base. We have implemented Python bindings for things such as prototyping, scripting, and integration of AI/ML workflows, as well as also trying to couple multiple application codes that are based maybe on the same framework, such as AMRX, for instance. It's packaged for easy deployment on the perspective of the user, so with CondaForge, Spark, PyPy, on Linux, macOS, and Windows. We have an open governance model with a steering committee and a technical committee. We have a comprehensive documentation, although there's a lot of work that could be done to make it even more comprehensive. It's deployed through Read the Docs. We have examples there, and we're working on making some tutorials publicly available to lower the barrier for new users and developers as well. So, why did WarpX join HPSF? Well, we share the mission of producing sustainable high-performance scientific software. We are certainly driven by the desire to learn and share best practices when it comes to scientific software engineering. We would like to address cross-cutting challenges that relate to HPC, such as continuous integration, portability, documentation in the sense that I will explain a bit later. We would like to build bridges with other scientific codes and with other scientific libraries in the community. We've had a very successful experience co-working with the MRX team at Berkeley Lab, and we would definitely like to maintain that kind of approach going forward. And we are committed to open science, transparency, and reproducibility, which I think aligns well with the HPSF. And as far as involvement goes, going forward, we would definitely like to share lessons learned from the experience of developing exascale codes, in particular PIC codes such as WarpX. We would like to collaborate on CI and testing infrastructure for this kind of large-scale code bases. We would like to contribute to and benefit from the existing working groups, for example, continuous integration and benchmarking, for sure. And we would like to, for example, exchange strategies and learn how other teams function and work, and how other teams develop their software when it comes to documentation, deployment, user support. And we would like to engage on any emerging topics to be up to date with the community overall. So we are currently experimenting with a couple of pilot projects for super facilities that orchestrate HPC simulations, experimental data from lab experiments and AI/ML workflows. And we would like to certainly know how other people have been doing that, if any, which kind of tools you have been using, and so on. We have a comprehensive regression suite of regression tests, but I think we lack a little bit of a well-defined, robust framework for proper unit testing for an application code like WarpX, as well as a code coverage framework that allows us to know very well which kind of features have been actually covered by the CI and which are not. Because we're growing in terms of algorithmic options that we support. I think it's really escalating, and we need to be able to know how to approach this in a way that is as comprehensive as possible when it comes to all the possible combinations of options that your code supports. We would like also to have, I think, some kind of framework of software quality when it comes to documentation, for instance, or code doc strings for automated API generation. I think we don't necessarily have a framework that allows us to set the bar for a standard to say, okay, this is, this piece of the code is documented well enough. We don't have a mechanism, I think, to do that in a systematic way. And that would be very, very important, because you have a code that is being used by hundreds of people, but you want to make sure that it's also well documented, and the documentation sort of scales at the same pace as the code itself. And also, when going open source, the number of contributions started to grow, and we would like to know how other teams manage these kind of large numbers of contributions that come in forms of issues or pull requests and such things. And this is probably also going to increase even further now with, I think, the wide spread of AI assistance in coding. I think there's going to be an increase in amount of code lines per unit time that come into the reviewer table. And we would like to sort of have a, think about like how we can scale the process of managing those contributions in a way that makes sense. And that's it. So the takeaways: WarpX is an exascale high-performance peak code for plasma physics simulations. Essentially, it's focusing on accelerator research and fusion research. It exists thanks to the Department of Energy, thanks to the MRX team, certainly, and now thanks to HPSF, and most importantly, thanks to all contributors over the last 8 years. We welcome very much feedback and collaborations from participants here, and we welcome everyone to join us, on or connect with us on GitHub or Slack whenever appropriate. So I'll leave you with the list of people involved in the steering committee as well as the technical committee, and a photo of our last year's hackathon at the NERSC facility at Berkeley Lab. Thank you.
Edoardo. Questions for Edoardo? Anyone? Yes. I'm going to watch out going over here to Andy.
So you quite rightly stated that you're so far the first sort of pure application, excuse me, application that's part of HPSF. You touched on a lot of this, but I really would like to give you an opportunity to sort of dig deeper into what's different about an application and what you think you can gain out of HPSF and what you think you can bring to HPSF as compared to a library or a system utility, etc. So I'd really like to give you an opportunity to drive further down there, because I'd really like to see us bring more of the open source applications into HPSF.
Yeah, it's a great question. So yeah, we're definitely an application code in the sense that we don't really provide necessarily tools for a broad range of application codes as well. Although there is an effort even within WarpX to kind of carve out, for example, shared modules of the typical particle in cell code that could be used by other codes as well. So in a sense, we are a little bit going towards a hybrid situation where we would like to be more of a sort of a scientific library for PIC specifically, and or at least part of what we would like to be. And as far as HPSF is concerned, so I think for now we've gained a lot of. So the thing is, I think we want to be able to grow as we move forward. The funding schemes always change and evolve quite dynamically, and we want to have sort of a stable framework that where we exist and where we can leverage contacts with libraries and with other teams to become better at developing the software that we develop. Because at the end of the day, we don't necessarily all come from a background of pure, computer science people. We are very mixed. We have a lot of physicists, mathematicians, and also I think the computer science support comes primarily from AMRX, for instance. And I think we would like to essentially really benefit from being exposed to all of the people that develop libraries and develop like HPC tools and toolkits, and and learn. And as well, I insist very much on the software development side of things, like learning how to work, learning how to develop software, how to address specific aspects of the software development cycle is something that we don't necessarily have the funding resources to focus on, because we're not funded for doing that. We're funded for producing science results. But we need to be aware of how to do it properly. We may need to also try to think of alternative funding schemes for such things, such as documentation or generally like software engineering, establishment of software engineering practices and so on. So this could be a venue as well for exploring extra funding opportunities for a code that is more focused on the science application, if that makes sense.
Okay, I guess we have time for one more question.
And how do you work with the WarpX people? Like, if some feature is missing for WarpX, and how do you contribute? And for example, so for if nitri CI against latest WarpX fails, how do you fix that?
Sorry, what's the last one? If
nitri CI against WarpX latest fails, in that kind of situation, how do you work with them?
So I think we are very lucky because we are like physically, geographically close to the MRX team. the core developers of AMRX participate to our weekly developers meetings for WarpX. And we also have a sort of a weekly meeting for the core developers and maintainers, so just a small subset of the WarpX people working together with AMRX to essentially address issues as they come up. We schedule work together, so when there is a new feature that we need and we see that it's coming, it's going to come mostly from AMRX, we essentially reach out and see if we can sort of set up a schedule for the feature implementation. And we are actively collaborating on Slack. So it's a very synergistic. It's like being part of sort of as if there was like a sub team that is essentially one team. Okay, we don't necessarily work on everything that MRX does. They don't work on everything that we do, but there is a large intersection. Yeah.
Okay, that's a lot of really good information. Thanks, Edoardo. And,